Hello. In our last video, we wrapped up by making our display class. And this is the front end of our program where it will pop up in a second. There we go. Where we can enter the information about our employee. The idea is we hit the submit button and then that information gets passed into some database or some way of storing the information about that employee. And then we can click this for sort entry, which will eventually mean that when I enter a name, it will sort it alphabetically. But this doesn't do anything right now. What we need to do now is we need to set up the employee class, which is going to store all the information about each employee. So this is the template to make employee objects. So I've come over here and I've made this class called employee, and I put a main method in it only for testing purposes. It means I can kind of do some testing. And I can construct an employee now. Employee E1 equals new employee. And I can construct an employee object. Again, this main method usually would be somewhere else, but this is just for quick testing. Now, I'm gonna set the stage for this, but it's really important before you develop a class, you really understand the needs of the client or the needs of your program, because an employee class could be written in a variety of different ways. So there are going to be some things I do, and you're going to scratch your head and say, well, I would do it slightly differently, or why did you do this? Again, this is all about learning and understanding the structure of a class and classes and what an object is. So there's flaws in it, and it's good to kind of question that. But remember, ultimately right now, the purpose of this is just to kind of get you comfortable with this concept. So I'm going to paste these fields in here, and this is how I've decided to kind of structure my employee. All employees are going to have a name, which will store full name, their age. This will be an employee number, a unique ID, and this is I've included this because this allows us to show a really useful application of static variables. In the AP exam, this comes up every now and then. And job title, so this is my job title, so whatever the person's doing. Job, well, it's pretty clear, job title, there we go. And then a payment. Payment's a Boolean, 0 for salary, 1 for hourly. I've decided not to put the actual payment inside there, the value in here, partly just to keep it simpler, but also you could think about it as a way of protecting information. Maybe there could be a situation where the people who have access to the employee files, we don't want them to know what the actual, how much they're being paid. So this is kind of a way of protecting information. And I can, now I can run this and no problem. The last thing I have, is I have this static field called total employees. And remember, all a static field does is a static field is a field that is shared amongst all instances. So there's one copy of total employees, and if I change it for one object, it changes for all of them. So I come down here, and this still runs. Remember, this is our reference type equals new object type. And again, at this stage, the reference type and object type are always going to match, but as you get into more advanced topics and start looking at hierarchies, these don't match all the time. And thinking in terms of reference type and object type becomes really useful when we're kind of diving into some more complex coding situations. So I want to build a constructor. So the constructor is always public, and it has the same name as the class, and it's going to take a string and int a string JT and Boolean P. So it's going to take 4 parameters, and I'm going to set the name equal to N. I'm going to set the age equal to A. I'm going to set the job title equal to JT. And I'm going to set the payment method to P. Now, you'll notice right away I get an error here. The reason I'm getting an error now is because the minute I write a single constructor, the default constructor disappears. And that's kind of just something we need to know. So this is an error now because of the fact that we have our own custom constructor. So let's pass some parameters into here. Person 1, and they're going to be, 45. Their job title is going to be manager, and their payment is they're going to be on a salary rate. And so now, if we save this, we have an error. Let's see, where's my error? Sometimes I miss these things. Let's just find this. I realize I have a problem here is 0 and 1 aren't Booleans. False, true. There we go. So let's pass this false. There we go. Perfect. Okay. So we want to write a get and set method for all of these. Again, I don't know right now if I need them in terms of my display, but we're just going to do them because they're good to understand. So remember, get and set methods are accessors and mutators. Accessors access a value in some way. Mutators change a value in some way. So public string get name return name. I often just write these in one line. Public string get age return age. That's an int. Public int get employee number. You're noticing that I haven't set the employee number right now, I hope, but we'll do that in 1 second. Return employee number. Public string get job title. Return job title. Public. Now, public Boolean get payment. Return payment. Now you'll notice here there we go. Why is this giving me an error? Oh, I should spell Boolean right. Now, let's just for understanding, let's make a get total employees. But because this is a static variable, it's going to be a static. Public static int get total employees. Return total employees. There we go. And again, the reason why I want this to be a static method, oh, I forgot there we go. The reason I want this to be a static method is because this is a static field. Remember, the thing about static fields is that they're shared amongst all instances, but in a static method, I can't access instance fields, and the reason is because we call static methods with the name of the class, not with an instance. So for example, if I just decide to return age here, I'm going to get an error, and the error is that because this is a static method, there's no instance, so it has no age variable to return. But because total employee is shared amongst all instances, it can return that no problem. So now I'm going to pause this and do all my set methods. Okay, so total employee, there we go. So I've made all my get methods, I've made all my set methods. I really want to stress the point here that I'm simply doing this just so you understand these as a principle. A lot of these set methods don't make sense because I wouldn't necessarily set the total employees unless I constructed a new object. So understanding that the system itself is really important when you're designing a class. And that's something that the IB talks about a lot, understanding the system, and then how do you get information to understand the system. You know, you can do surveys, you can do, focus groups, panel discussions, whatever that is. I just really wanted to set all these up so that you kind of got an idea about how to do this. Again, these are needed because of encapsulation, all these get and set methods. But what would be really nice here too is that you could put your error checking inside here. I'm not going to do any error checking. Now you probably noticed that I didn't actually set our employee number. So here's the thing. Really what I really wanted you to kind of get an understanding of is we're going to use this total employees to set our employee number. So our system is going to be that your employee number is assigned based on the order you are hired. Okay? So what I can do is I can say employee number is equal to total employees. Now, because total employees is a static field, it means if I increment it for one instance, it increments it for all instances. So it's a way of tying all the instances together. So then what I do is I say total employee equals total employee plus 1. total employees, pardon me. So this is actually a really powerful technique. And actually what we're doing here is we're simply keeping track of the number of objects that are created. So let me show you. If I come here and I copy this and I make a second employee, let's call this person 2, and then I'm going to do, let's call this E2, and now what I'm going to do is I'm going to do system.out.println, and I'm going to print line E1 dot employee number dot E1 dot get employee number. And I'm going to do now employee dot get total employees. Notice get total employees is static, so I call it with the name of the class. And now I'm going to do the same thing for E2. So if I save this and give this a run, you see employee number for E1 is 0, employee number for E2 is 1, but notice how total employees is 2? And the reason why that is because every time we run through here, we're incrementing total employees by 1. So because what happens is I've constructed employee 1, so what happens here is what my employee number is equal to 0, and then I say total employees equals 0 plus 1 because there's initially 0. And I just say EN, that's going to make it a little easier to read. So now what happens is when the employee number gets set for employee 2, because this static field, total employees, is 1, it's going to become 1. But then total employees becomes 1 plus 1, which is 2. So what this total employees is doing is it's keeping track, is incrementing every time I create an instance. This is a really powerful technique, and I want you to keep this in the back of your head. Okay, next thing I ask you to do is to write a toString method. So toString methods are a special method, public string toString, return just that for now. I really want you to note that this is an overridden method. Remember, the object class has a toString method, and so currently, if I delete this for a second and I do something like system.out.println E1, and I run this, I get the object, I get the name, the object type, and I get the actual memory location because the toString is being drawn from the object class. But if I write my own toString and we say what toString is going to do, it's going to return the job title, so it's going to say job title plus, and then it's going to give me the employee number. Oh, it's going to give me the name plus, and then the employee number. So there we go. And now if I go system.out.println E1 and I run this and I say okay, there we go. Manager person 1 0. And if I do system.out.println E2, I say okay, manager person 2, employee number 1. Again, this is heavily driven by the context of your system. The toString doesn't have to print out everything. My client's going to tell me, how do I want that information displayed to the screen? The last thing we've been asked to do, the last thing we need to do is create an equals method. So I'm going to say public boolean equals, and I'm going to take an employee object E, let's call it other. And remember, the first thing we do when we write an equals method is we always check to ensure the pass parameter isn't null. So I'm going to say if other is not equal to null, and then I'm going to return. And the way we check, in this case, again, our system says that we're going to say two employees are equal if their job titles are the same. That's it. So I'm going to return this dot job title is equivalent to other dot job title. And then otherwise, I'm going to return false. Oop, there's Python in me. Okay, so there's my equals method. And the really big thing I want to draw out here is we always do a null check of the pass parameter. We don't have to null check the implied object because we wouldn't even be able to get to this point, because it's only when we construct an object that the function gets made. And that is my employee class. So in the next video, we're going to take a look at how do we take this employee class and use it with our display class. I hope this helped. If you have any questions, don't hesitate to ask.